Welcome everyone. It's a pleasure to have you here, and it's a pleasure to chair this webinar, which is an IEA webinar belonging to the webinar series on resilience engineering, organized by the IEA Technical Committee on Resilience Engineering. The scope of this webinar is actually about one of the most notorious methods of resilience engineering, which is the functional resonance analysis method. And the title of this webinar is Navigating the FRAM. Actually, we'll take advantage of a very recent update in the FRAM literature, which is the latest book on the functional resonance analysis method, which will be officially released tomorrow, and a book that I had the pleasure to edit and to see published eventually, thanks to the collaboration with many colleagues around the world, some of which are here co-presenting in this webinar with me. Sorry. As I said, this is made possible thanks to the support by IEA and all the people in the technical committee we chair. You see, the agenda of today starts from the book itself and will be chaired by me, but accompanied by a kind of short and focused presentation, respectively by Geisa Pretorius, Tarcisio Saurin, Ari Adriansen, Mark Sujan, and eventually I'll take over for a slot dedicated to question and answer. But before jumping to the introduction of the book itself, let's take some moments to allow our speakers today to present themselves. And I will start with Geisa.
Yes, hi everyone, I'm Geisa Pretorius. I'm a senior researcher at the Swedish National Road and Transport Research Institute, and I also work as an adjunct faculty at Linköping University in Sweden and the Norway Western University of Applied Science. I will take you on a detour through shipping and marine pilotage today. Just a short one.
Thanks, Geisa. Then the floor to Tarcisio.
Hi everyone, I'm Tarcisio Saurin. I'm speaking from southern Brazil, where I'm a professor of industrial engineering. And I will present a chapter on FRAM used in combination with lean production for waste management in health services.
Thanks, Tarcisio. Floor to Ari then.
Hello everybody, my name is Ari Andriaanse. I work at the Delft University of Technology in the Netherlands under the Department of Multi-Actor Systems. And together with my colleague, I have written a chapter for this book. On the other hand, I'm also the co-chair of the International Ergonomics Association, which is supporting us today on the Technical Committee Resilience Engineering, chaired by Ricardo.
And last but not least, please, Mark.
Hello, my name is Mark Sujan. I'm Professor of Safety Science at the University of York in England. My chapter is with my colleague Oliver Lounsbury, based at Oxford. We will look at how you can maximize the impact of your FRAM analysis.
Fantastic. So thanks for this very short introduction. Of course, we will learn more in the next few slides. But before approaching to dedicated chapters that any of you has led over the past few months or years, actually, from the initial inception of this book, I think it's worth investigating on why in 2025 we need this book, or why this book has been conceived. And to be honest, maybe all of you knows that the very first introduction of the FRAM as a method at that time actually was a model in the acronym, dates back to 2004. Clearly, it was due to the initiative of Professor Erik Olnagel, which of course we thank for the amazing contribution given to the field of resilience engineering and on the FRAM itself. But at that time, I didn't make a mistake in the spelling. It's simply that at that time it was called the functional resonance accident model. So a model rather than a method. 2004, 20-ish years ago, what happened since then? The stars that you see on this graph represent two milestones. The first one is the 2004 chapter, and the second one is the 2012, where it has been released what is nowadays considered the official handbook for the FRAM usage. But in 2012, there has been a big change in the significance of the FRAM acronym, and of course, even more importantly, on the actual approach usage. I'm using approach as a neutral term because in 2012, that has been renamed as the functional resonance analysis method. So no more an accident model, but an analysis method, which to some extent broadened its perspective. And you see in this graph the evolution of the number of like indexed papers. We just, for simplicity, used Scopus only as a search database in relation of time. And you see there has been quite a big increase over the recent years, which to some extent is due to the widespread of the method, even to the applicability discovered by research initiative, in some cases by industry. So essentially, this means that there are approximately 20 years, or at least initially that was the reason to start the work in 2023, to see it published in 2024 and mark that as 20 years after the very first injection into the academic and industrial literature. I think if you are here is because you are somehow interested in the dichotomy of work as imaging, work as done, and then that's part of the story. So we ended up in 2025, slightly late, but that's somehow 20 more years after the first injection of the model at that time, of the method. And at that time, I thought that was a good moment to collect and ask experts working on the method for years to contribute to a volume that is what eventually has been released nowadays. So, we had the reason for a book. We don't have a title yet. So why this title? Why navigating the FRAM? Because maybe you're familiar with the idea of the FRAM as a ship, the one that you see in the picture. And also for those of you with some Norwegian language background, FRAM also means forward. So, FRAM is a ship that was a bit peculiar in their sense, was an Arctic exploring ship, which somehow gives to some extent also the reason behind the book itself and the FRAM as Eric already acknowledged. So it's like saying metaphorically that this book is attempting to show how the FRAM as a method nowadays has the potential to navigate through the seas of complexity and abandon linear explanation towards something more. And we start with this idea, like we want to navigate the FRAM, we want to understand how to use the FRAM, how to make it as a valuable asset for our operational and organizational processes. And out of that, we have a subtitle to further specify that we're not talking about ships per se, but we're talking about mastering the function resonance analysis method for modeling complex socio-technical system. So essentially, for years, we try to understand systems as behaving from A to B, like what you see in the middle of this slide in the box. But inside the meeting room, inside the procedure, that makes a lot of sense. It's tidy, it's predictable, it's even reassuring to some extent, especially if you are in charge of a safety of certain process. But when you go outside, or when you look at it from the outside, there is much more complex and intertwined reality. So there is relevance of understanding interconnectivity, of understanding dynamicity, feedback loops, dependencies, surprise. And all of that can be analyzed by the FRAM as an approach to investigate this type of complexity. So again, coming back to the idea of navigating the FRAM is because what the FRAM as an approach helps us, or is supposed to help us doing, is to navigate this complexity. So not necessarily simplify that or trivialize it, but navigate it and acknowledging that it emerged from a very intricate web of interconnections that make a system either resilient or brittle, depending on the circumstances. So the next question is, okay, we have a book, we have a title, but why should you read it? First, because somehow it's capturing and synthesizing years of experience by different scholars and aims to be a sort of a compendium for up-to-date expertise in using the FRAM. Every chapter has been written and edited in a way to offer a balanced perspective. So we're not saying just, oh, the FRAM will be the solution for any of your system problem, or you will be the perfect method you're going to use, but we try to offer that as a balanced perspective, understanding use cases or limits or constraints in doing so. And of course, to do so effectively nowadays, it means to ensure that we can have access to real-world applications. So every chapter is embedded with a real-world application, with a real-world case from a different domain to explain the details on that domain and support cross-domain learning, which is indeed what we want to capture as a final result. So ensure cross-domain insights. Okay, hopefully you are convinced that it's worth having read to this book, but then how? How should you read this book? And you know, when I was thinking on a book about the FRAM, I realized that there could be various interested readers. So, you know, the usual way of reading that is like as a curious person, like you go for a book, maybe you are not fully aware or you're not very expert into the FRAM, so you use it and you read it from A to Z, like a standard way of reading that. But we expect that there could be domains experts into the book. And by domain, I mean, for example, sheep experts, with reference to the chapter that Geisa authored. You know, there is other chapter. There are other chapters about ship's operation, but let's make this an example. Or you know, the chapter that Tarcisio authored about healthcare operations. So it means that you can be one of the domain experts. So maybe you're not very expert about the FRAM, but you know well the domain. So you may be interested in reading with certain attention a certain portion of the books, which may resonate even more with your current expertise. And that's one way of looking at that. Or on a side note, maybe you are more on the method side. So you're a method geek, like you know well how the FRAM works and you want to just be at the pace with very recent updates or, you know, years of updates summarized in one of the chapters. So essentially, every chapter is built in a way that allows you to spot sections that are particularly relevant for you as a domain expert or as a method geek. So imagine this chapter that comes from the excellent work done by our colleague Rihanna Steen and James Norman, where they talk about aviation case. There are portions of the text that are clearly labeled as domain experts. You see them in blue here. So those are portions that, you know, if you skip it because you're not really in the aviation world or you are not interested in the aviation world, you can still get to the content of the chapter, to the meaning of the chapter, but without, again, the details that make you fully confident in understanding the specific case they're looking at. And the same applies for you know, the methods geek section. I'm taking this excerpt from the brilliant chapter by our colleague Andrea Falegnami, supported by Andrea Tomassi, where they performed a literature review on the FRAM. And for example, you don't necessarily need to be aware on which specific algorithm they use to run the analysis, but in case you are, that section is preferentially marked as method geek section. So, that's the book, that's how it looks like, but how did we get there? And I'm on purpose using we, because this is a collaborative and collective writing exercise, essentially collaborating. So we get there after tons of meetings, after tons of interactions, which I try to quantify afterwards. And nowadays, in the map you see, you have placeholder generically put in the country of the institution of the authors involved, but we have something around we have no less than 33 authors, 22 reviewers of dedicated chapters, 14 countries, authors coming from 14 different countries and 4 continents. So it's quite a worldwide exercise, which was supported by 7 remote plenary meetings. We didn't have the capability to meet in person altogether, while though we used other conference to have dedicated meetings. Something around 800 emails over the past 2.5 years, plus I'm not counting any interaction on phone, message, and whatever. And we start with a table like that, tentative title, tentative chapters, and progressively ended up with something where every chapter has been submitted, reviewed, resubmitted, re-reviewed, edited multiple times. So what is the content of the book? And that I know will be just a very quick introduction, something that in aviation will be called a 30,000 feet view. So we see it from a very abstract perspective. So we have a prologue section to introduce the book, then sections dedicated to each of the building step of the FRAM. So four section, each one supposed to refer to step 1, 2, 3, 4 of the building process of a FRAM model. And then we have a discussion section, and finally an epilogue section. In these slides, but that's something you can get anyway online, you see the introduction to the what is considered the most relevant and up-to-date approach, more up-to-date observations about the FRAM. So an introduction first, then something that Eric Nagel wrote like as an official history of the FRAM itself. Then a formal representation of the building principles, the building steps and the principle of the FRAM, compared with an up-to-date literature review to really focus on what recently has been published on the FRAM itself. Section 1 is about the very first step of the FRAM building process, so to identify and describe function. And we go all the way from very simple models called small FRAM models, which anyway can carry an invaluable potential, an invaluable learning potential for the system, all the way up to identifying function through mixed approaches, or even using AI and large language models, and leveraging on semantic lifting is called. So, hybrid, making even more hybrid the story. This is paired with section 2 about variability, and we have the very first chapter introduced that would be about GEISA, then fuzzy representation of variability, and then lastly, a discrete event simulation of variability. Section 3 will be about aggregation of variability. And that will be done in various ways. So through Monte Carlo simulation, network theory, machine learning, and IEA. IEA is not a typo, it's interdependency analysis, but Ari, as you see, will be the second speaker in this regard. And then we have section 4 about the management of variability, which will cover what is called dynamic variability modeling, and then coming to example that refer to lean operations, or again, understanding the real impact of a FRAM analysis, thanks to Tarcísio and Mark, which will be respectively the next speakers. We have section 5 about the software used to do that. One of the software used to do that, the most frequent software used to do FRAM analysis, called FMV, and then FRAMing the learning process that the FRAM model can support. Eventually, we'll look at the glossary preceded by like a critical chapter about to FRAM or not to FRAM, coded by me and Geisa. But given this initial presentation, I would hand the floor to Geisa
Yes.
to introduce herself and present their case.
Yes, so hi again. So it's my name on the slide, but this has been co-authored and co-worked with me with Amit Sharma. And Amit is also in the webinar, so everything that you ask and want to know, Amit can probably also answer. So just to give him some credit. Next slide. So we're trying to do this. We looked at a problem which is navigational support from shore. So it's kind of remote marine pilotage, and marine pilotage is under change. So in the left-hand corner, you see the traditional way a marine pilot is a navigational expert that goes on board and assists the crew to go to berth or go out of port. So it's very complex navigation, and normally the pilot is kind of a local consultant that takes the communication with the local services and also helps because he or she knows the waters. It's an expert. However, the job is very dangerous, inherently very dangerous. As you can see, there's this tiny pilot boat approaching a container vessel. So pilots actually embark and disembark on moving targets, which they do in all different types of weathers. So it's very dangerous, both for crew, for vessels, for the pilots themselves. And as we advance in technology, there is the question, can we move the pilot? I mean, we do a lot of synthesized training in simulators. As you can see here, there's the pilot training, actually. And we have the technology at hand. So can we move the marine pilot ashore? And can this person provide marine pilotage from a shore station? And this is an ongoing research project in Sweden, financed by the Swedish Transport Administration. And Amit and I thought it would be very fun to look into that with FRAM. So you can see the remote pilot is sitting in front of pilot station there to the right corner, at least on my screen, I hope on yours as well. And you can see the pilot is monitoring the area of the Gothenburg Harbor approach, and he's providing marine pilotage. As it's a safety critical system, currently this is only done on some sea trials, but mostly in simulators. And also, you may wonder, why do we want this, beside the fact that it's dangerous and complex? Well, we also have a shortage of maritime workers, which of course also translates to a shortage of maritime senior officers that are potential pilot trainees. So somehow we hope not only to make the job safer, but also kind of attract a new type of workforce and also present a nicer work environment. So next slide, please. So we wanted to use, in this project, we wanted to use FRAM basically to explore the differences between marine pilotage and shore-based assistance. So are they doing the same thing, or are they doing something different? And if so, how do the differences translated between what they have now designed as a procedure, so it's a system under development, and how it is practiced within the simulated settings. And we also wanted to see whether there are new constraints and new risks, but also maybe new opportunities in the cooperation between different services, given that you're creating a shore-based service. And from a researchy point of view, we wanted to see if we can use FRAM to assess kind of what is the system design and what are the implications of the design on training, on the organization, but also on how we have to rethink the pilotage system. Next slide. So, and you can read this in detail in the chapter. So these are just snapshots. We did actor interviews as a basis for the data collection. And then we transformed, we both did task diagrams through the actor, but we also did hierarchical task analyses, both of normal pilotage, and that was helped and assisted by Johanna Larsson and Cecilia Berlin. So this is normal pilotage as a task diagram, and you see it's basically 3 phases. You prepare yourself for the pilotage by familiarizing you with whatever vessel you will provide pilotage services for. You make a passage plan, you check the environmental condition, and then you do the actual pilotage, which is basically you go on board, you find your role within the bridge team, whether you're assisting or actually navigating actively. You navigate the vessel jointly with the bridge team, communicate with all the services ashore, and then you maneuver to berth. And for non-maritime people, that means you park the boat. Next slide, please. So already when we looked into just the task diagram, we realized that navigational support from shore is largely different because, well, you not only kind of prepare, pilot, and berth, You also have kind of more advanced traffic planning. You need to establish a different type of contact to the vessel. You have to advise in a different way. So the pilots mentioned that you have ordinary advice where you just say what you would normally do, but in a different place. And unexpected, that is when the signals that you see do not really match what you expect it to be. You have to monitor the crew, and that gets very messy if you're not co-located, and you have to communicate. So next slide, please. We realized that all of these are activities that create a need for adjustments and for a lot of adjustments. So we wanted to know what is the complete and complex picture of the activities that a shore-based pilot conducts, but also how does that fit into the system between the crew and the pilot, and what do they do jointly, and what do they each provide to each other? So next slide. So we did a FRAM, and that looks messy. And I know that this is one of these things you should never show a full FRAM model in a FRAM presentation. But I just wanted to give you a snapshot, and you can see the model and the description in detail in the book. But this is just to show you, well, we can make a very simple picture of what is happening, and then the difference might not be that big between normal marine pilotage and navigation assistance from shore. But as soon as you put it in a FRAM, you see all these nitty-gritty dependencies and how different functions and activities feed into each other. So next slide, please. What we basically saw, it's not just a simple move. And for everyone in human factors, that is not a surprise. However, for some of our experts, it was. Because what we saw through the FRAM is that the marine pilot gets a completely new role within the maritime transport system. There are new dependencies and new complexities that you have to face. Well, you don't have to berth a vessel anymore. However, as one of the pilots says, well, it's like to be in the back seat. It's like to pilot defensive, definitely. Much more defensive than if you are on board. Well, it's also new tasks and cooperations and orchestration. Orchestration is how you manage the interaction with vessels and services and how you plan and adapt and adjust your work. And within the FRAM, we can see how a pilot orchestrates this. So they take the workload for turning the ship, they is the crew, and I take the load of the traffic. So this is what it will be in the future. A remote pilot or an NSA pilot, they can just focus on the traffic. So we see there is this changes in task and the change in focus and this change how you cooperate and orchestrate around your work. And also, of course, new demands, new information or lack thereof, and limited potential to recovery, as we see in the next quote. It's also hard to change over. When you get to information that, okay, here's something big and challenging that I didn't know until now, to try to figure out a way to solve that problem. So given the situation that you're not co-located, there might be things that you just don't see in your navigational system that is ashore, because you're all dependent on sensor inputs. And nonetheless, in today's situation in the world, it's easy to put out a signal. It's also easy to take it away. So if you don't see it and if you get the information late, how will you recover? And that is also something that we kind of started to put our fingers into with the FRAM. Next slide, please. So why is FRAM important here? Well, it uncovers complexity of work and complex settings. Oh, it helps you to draw a very complex picture that you can show as well. But anyhow, it helps you to see the different dependencies and helps you to reason around these. And it's a system under change. So it's under development, and it can help us track what are the consequences of changes. And it can also help us to play around. So if we change this type of function or this activity, what happens with the rest? It considers jointness of work in complex settings. So what we thought was very helpful, and also the pilots that we have worked with, is that you don't split between people and technology. You see how these things work together, and especially in a situation where work is technologically mediated and you teamwork through radio, this is very useful. So it helps you to see what are the resources that you have, what are the preconditions, and what are the coupled activities that the system has to conduct to succeed. In the end, everyone wants to be safe. So how do we achieve safe and efficient operations? Well, and it also, in our case, helped to synthesize and analyze information from simulation, observation, and interviews in a systematic way. So FRAM actually helps you to abstract from the raw data. And I know I show raw data quotes, but if you read the book chapter, you will also see how you can find variability and see these transcripts and actually transform these into a functional model. So that's the selling point for reading my chapter and Amit's chapter. Yes, and next slide. That was already all I had to say to keep us in time. So thanks a lot for the for the attention. I hope you got really excited about maritime operations and FRAM.
Thanks, Gesa. That's of course I'm biased, but that's an exciting chapter and is paired with another exciting chapter on maritime operation authored by Doug Smith, who is not in the webinar today, but your two chapters together somehow offer the baseline for ship-related operations. You tackling more qualitative approach for the method side, Doug approaching more it quantitatively, but I think they both offer a very valuable basis for any expert or anyone interested in checking the FRAM in maritime operation. Thanks, Geisa. An extra thank for making it due to your personal busy agenda. So if that's okay for you, Geisa, I'll shift to another interesting chapter by Tarcisio then, which is linked to the usage of the FRAM in relationship with the idea of lean thinking for coming from Toyota production system and industrial engineering. So I'll hand over to Tarcisio for presenting his chapter and how this is somehow relevant for FRAM users nowadays. The floor is yours, Tarcisio.
Okay. Thanks for this introduction, Ricardo. This chapter reports a consulting project we carried out last year in a nearby hospital. It was developed by myself and some colleagues from the industrial engineering department and some PhD students. One of the co-authors, by the way, is in the audience here, my colleague Flavio. Next slide, Ricardo, please. So in this chapter, we explore a new application of FRAM, or at least an underexplored application, which is related to the use of FRAM for analyzing variabilities that create wastes in production systems. We are using the waste definition from lean production, which defines waste as the use of more resources than necessary or an unwanted output from a function. And an important assumption of our chapter is that several or all concepts underlying FRAM regarding system complexity, functional resonance, these concepts also apply to waste management. This is important to emphasize because these concepts are usually presented in the context of safety management. So we think this is an important new perspective to apply FRAM. Next slide, Ricardo, please. So in line with the lean production approach, we are using the lean production taxonomy of wastes. It's probably familiar for some of you. Lean production proposes 8 main types of wastes, for example, transportation, inventory, motion, overproduction, and so on. And there is also a resiliency justification for the proposed approach in our chapter. We think, and this is based on several prior studies, that waste elimination can benefit resilient performance. This can occur because waste elimination reduces unnecessary complexity and it releases resources that can be used to enhance adaptive capacity. But we are also aware of the risks of combining applying lean in complex systems. The chapter recognizes the possible conflict of short-sighted lean initiatives that confuse value with waste. And this distinction between value and waste is not straightforward in complex systems. So it's important to be careful about applying lean under highly complex conditions. Next slide, Ricardo, please. And moreover, we have been working on lean and resilience for several years. And the literature also supports the point that lean initiatives are often based on linear models of production systems, and therefore they offer incomplete solutions. So there is good reason to bring the complexity perspective from FRAM to be used jointly with a lean project. And in more practical terms, this chapter demonstrates how the waste analysis perspective impacts each of the traditional FRAM steps. And we make this demonstration based on a case study of using FRAM to analyze waste in the sterile unit of a hospital. Next slide, Ricardo, please. So maybe maybe a few people here are familiar with hospital environments, but just a brief overview of what a sterile unit looks like. This unit supplies surgical instruments and gowns to several hospital units, especially the surgical unit. And there is a strong interaction between the sterile unit and the scheduling of surgical procedures, because this schedule poses the demand for the sterile unit, and it sets a basis for work organization at the sterile unit. And even though the sterile unit looks like, apparently, it looks like a linear process, there is a lot of complexity involving the interactions between the sterile unit and other units of the hospital. And the main interaction refers to the surgical unit, as I said, and there are many unexpected events, many disruptions, many changes that hinder the schedule and that demand resilient performance. Here you can see some images of what a sterile unit looks like: trays, sterilization machinery, the storage room. Next slide, Ricardo, please. And so the more practical part of the chapter now refers to the use of the waste perspective, of the lean perspective in each of the FRAM steps. In FRAM step 1, which is related to the identification of functions, we emphasize the importance of including functions related to both adding value and non-adding value functions. Adding value functions are those that fulfill customer requirements, which in the case of a hospital relates to the patient. And wastes occur in both types of functions, adding value and non-adding value, but the non-adding value functions are more frequent. In most systems, they are more frequent, and they can often be eliminated without compromising system functionality. So non-adding value functions are good targets for improvement. Next slide, please. In FRAM step 2, related to the analysis of variability, we developed a matrix like the one on this slide, where we list the functions on the rows and the waste types on the columns. And then based on this, it's possible to identify the functions most often associated with wastes. And it's also possible to identify the most frequent waste types, which in our case study were those highlighted in red: motion and defective production. Next slide, Ricardo. Well, I think that a very important conceptual contribution of this chapter refers to the interpretation of the meaning of waste types in a FRAM model. I will just give you a quick example here. On the top of this slide, we say that overproduction in advance in a FRAM model means that the output of an adding value function is produced too early. So this translation of concepts is crucial to develop a FRAM model from the waste analysis perspective. Next slide, Ricardo. In FRAM step 3, actually, there is nothing special about our proposal here. In the chapter, we just presented an instantiation of couplings during everyday work, and we presented the systemic impact of overproduction by quantity. This is our FRAM model, and the functions highlighted in red, they are the functions affected by overproduction by quantity. This waste occurs because the sterile unit usually processes more trays, more instruments than required by the operating rooms. And so all instruments go all the way to the operating rooms and they return unused to the stereo unit. So there is a feedback loop, which is very interesting to be explored through FRAM. And regarding FRAM step 4, which is supposed to be the main focus of our chapter, we propose 3 courses of action to develop improvements based on a FRAM model. The first course of action is related to the elimination of unnecessary variability. This is an application of the lean perspective. We present an application related to the revision of the surgical trace composition, making the trace fit to the real demand of the operating rooms. Next slide, Ricardo. The second course of action is related to coping with residual variability, and this is about applying the resilience perspective. We present an example of creating an inventory of instruments that used to be frequently under corrective maintenance. In the real application, this inventory was placed close to the workstations for the assembly of trays. And the third and last course of action is related to enhancing desirable variability. This is also related to resilience. And in the chapter, we present an example of expanding workers' multifunctionality. And we show in the chapter how this benefits the resource aspect of all human functions in the model. Next slide, Ricardo. So finally, the main takeaways of our chapter. We present very practical guidelines for applying FRAM in waste analysis. We expand perspectives beyond safety. A more practical lesson learned refers to the use of a modeling team, including members with expertise in both resilience and process improvement. And the chapter makes it clear that lean and resilience are complementary in step 4 of the FRAM. And it also reinforces FRAM as a platform to analyze different facets of variability related to safety, quality, and waste management in our case. So thank you very much. Here you have my contacts.
Thanks, Tarcisio. That was I know challenging to describe the entire experiment and results and methodological advancement you made in a short time. So thank you for your summary here and your availability for presenting your chapter. And of course, the thanks extend to all your colleagues who patiently and contributed to the chapter and delivered that super on time. Thank you, Tarcisio. You know, we're talking about lean, so human and equipment interactions, or I would say interdependencies, because that's to me something that clearly connects to chapter 15, which is something that Ari led together with a colleague, Polina Zurawska. And, you know, it's again a sort of summary with one of the potential extension of FRAM, and again, an overview on how that applies into practice. What is the added value for that? So I'll leave that to you, Ari.
Yeah. So hello again, everybody. So this presentation is on behalf of Polina Zurawska and myself. We've written the chapter together, both Delft University of Technology, as was said, within the Department of Multi-Actor Systems. To understand multi-actor exchanges, which is what we study, we're going to use something which is called FRAM IA. So like Ricardo mentioned, it's not AI, artificial intelligence. You see the asterisk, it's interdependence analysis, which we mean here. We really also like to thank Ricardo for the book, which is on the right, huge achievement for putting the FRAM book together. And let me show you chapter 15 of this book, which is, of course, but one reason to read it. So first, let's situate where FRAM extended with interdependence analysis sits in the methods. Next slide, please. There are 4 possible steps, as you know, in FRAM. You have the identification of functions, you have the identification and aggregation of variability, and ultimately, we're going to listen to Mark Sajan later, assessing the consequences of the analysis. Next slide, please. And this is where, of course, also the book structure just follows what FRAM is saying, the steps you have to do a full FRAM analysis. But the book is structured according to these 4 different possible steps. We're going to say something about the identification of the variability, but mainly, next slide, please. We will mention the aggregation of variability. So this is where the main focus is going to be. A very specific type of variability that we use is called this interdependence analysis to aggregate it into this FRAM extension. That's where we will deliver the biggest contribution to the functional resonance analysis methods. So let's first look at the legend where you only see one function. I will take you through this. Together we will use this just one single function, add information to it, and explain the FRAM IEA method step by step in 10 minutes, which is challenging. And typically we start with a traditional FRAM model. So you just start naming your activities like you would do in any FRAM model. Thereafter, I'm also going to show the actual demonstration model later on in the presentation, so you actually get a feel of what we can do with it. But first, let's look at the second step. The second step shows 3 new things. This is the first layer where we extend the FRAM with something which is new, and this is essentially the interdependence analysis. It consists of the levels the labels O, P, and D, which stand for, if you look at the top left, observability, predictability, and directability. Because interdependence analysis is an extra layer on top of, if FRAM would be the what is happening, the activities and the functions, the name of these functions, the OPD, or the interdependence analysis, in other words, would be that how is that communicated and coordinated between agents, whatever is going to happen in any FRAM model. So let's have a very quick look into observability. That would be the ability to observe what the previous function has produced. So not only what has it produced in terms of FRAM, but also how am I able to interpret that correctly and is it reliable? The same with predictability, but there it would be the ability to predict what the previous function has produced. And the directability is actually the capacity or the ability to either direct or redirect what that previous function has provided downstream to the next agent. So these 3 essential elements are interdependence analysis, and we're going to put that as an extra layer on top of FRAM. Next slide, please. You now see appearing something at the bottom, which is even more information. Let's go not too deep into that. I will explain one more, but essentially what we're looking at, we're concentrating on that top part of the slide where you see the OPD, because that's interdependence analysis. The other 3 things are just additional things which you can also use in other FRAM functions. Next slide, please. And one of these things which I will mention at the bottom is the system operating nominal or degraded. This is just useful stuff for when I'm going to explain the actual model with several functions. But it's not part of the interdependence analysis as such necessarily. So you can see these 3 steps. We build a traditional FRAM model, we added a layer of interdependence analysis, and we assign system degradation potential, which is especially in technical agents and things with sensors and indicators and instrument readings, it could be useful. Next slide, please. And there we go. We have the first model. It's still conceptual. There is no real case here. We're going to look into that later. But you can see how these first 3 functions, they only have either an O, a P, or a D label. There could be more. It depends on whatever that function needs or whatever that function has produced downstream. But the useful thing is, like I said in the beginning, this chapter sits in the aggregation of variability part of the book. So what you can see in the 4th function is that the OPD labels are just mirroring what has happened downstream. And this is where the aggregation of the OPD happens. And that aggregation of the interdependence analysis quality information that we get from the whole model downstream is now aggregated, and it is used to calculate the different options, which you can see on the right. Option A, B, and C, they represent different functional paths different possible outputs from this pivotal function. That's how we call it, a pivotal function, which is something new in interdependence analysis, resulting from the aggregation of what we previously have produced in terms of observability, predictability, and so on. So now we come to a practical example. From theory to practice, we have, with our chapter, demonstrated this as well, and there will be an animated model with a link in the book, which you can see then online. You can even see it in a dynamic way, animated. But we have applied this model to two applications because functionally they work the same. These are two systems. One is aviation and the other one is industrial robot systems, where the actors, being either the pilots or the plant workers, they are operating a machine or a system, and they're depending on sensors and instrument readings to know that they continue with the automation involved, which in aviation, of course, would be the autopilot. But as you can see, the thumb of the pilot on the left top picture is actually to put the autopilot off whenever that would be necessary, because the instruments are not reliable anymore. And at the bottom right, you can see the same with the automation in robot systems, where when something goes wrong and your systems are either not reliable or you get some information that you have to stop the system, you can revert to manual control, being an emergency stop with the robot system. And that brings us to the actual model. So what we can see here is on the top, it's just a reminder of the legend which we've been using so that you can better interpret on the bottom what is happening here. You can see that pivotal function. So keep in mind when we're going to start the animation, that pivotal function is the second orange function at the right. You see that there are three options, A, B, C, so to say. It's the one function that produces three outputs. And please start the animation, Ricardo. So what you can see happening now is that we're in the automated loop, and now it goes to the manual loop because some instrument reading has received a bad instrument reliability, or there might be a blocked sensor in the aviation case. And what finally happened is that we went to a third option. And this is the key takeaway from the model. That is, as long as we knew that there was something wrong and that our instruments were unreliable, we were still in a way of control. We were acting, or the agents in the system were acting according to the procedures. They went to manual flight or emergency stop. That would be the downwards loop. But we went into this red stop function, which means we lost two things. We lost not only the reliability of the instruments, but also the possibility to rely on these instruments. We lost our OPD capabilities. In other words, we lost the interdependence layer on top of this. So this is, if we go to the next slide, the key takeaway that the value from this chapter, but also from this methods, is that where FRAM describes just the activities which happen, we always had the possibility to attach phenotypes to it, and that would be traditionally in FRAM, that would be something like the precision or the timing, and that's also quality. And here with interdependence analysis, we have produced a very specific peculiar quality, which is how do we coordinate and communicate these things between actors, whatever is happening in a FRAM model. And these two things together provide the coordination potential, which is just that little extra, and which sits nice in the book in the aggregation variability part 3. I think Mark Sujan is going to say something about what do we do with the analysis afterwards. And if you have any questions, you can just write me an email. Thank you very much.
Thanks, Ari. Of course, you can write a question by email to Ari, but if there is any quick question you have at the moment, you can also use the question and answer functionality or the chat to do so. We'll try to see if there is anything coming up at the end there. Thanks again, Ari. Your chapter was very focused on a sort of methodological advancement and the implication for that in various cases, which I think you were quite successfully able to summarize in such a short amount of time, where again, interested readers will require a more in-depth read of your chapter itself, of the chapter itself. I'm shifting to the last presentation of today that's chaired by Mark Sujan. and is about a chapter written together with Olivia Lounsbury, which I think will greatly summarize a bit of the spirit of the book, because in this chapter we're going to see like lesson learned examples, do's, don't do's, on how to really run and maximize the impact of any FRAM analysis. So looking at whatever extension you may have, but seeing what is the implication in practice. But I'll hand over to you, Mark, to present the chapter itself. Thank you.
Great, thank you. If you just flip to the first slide. Thanks. Yeah, so this chapter is a bit of a reflective story in a way, where we looked at our own practice of using FRAM and what kind of lessons and maybe tips even we have picked up on the way. So, there are different ways of using the FRAM. Typically, the way I use it, and many other people as well, is we want to understand complexities of work is done. And specifically, we're looking at it with a specific lens. So I personally want to understand, how does the system adjust and how does it succeed under varying conditions, i.e. under situations of complexity and uncertainty. And then, of course, we want to make changes. So we want to make systems-based changes so that we improve the overall system performance. But, next slide, please. But of course, I'm as guilty as other people are. Frequently, there is this, obstacle that we explore work is done in a really detailed way. We show our FRAM models, and we're kind of proud of it because it looks both complex and colorful. But many of these projects are done in a research environment, and so often we walk away at that point where we hand over all our knowledge about this is how your system works, and now it's over to you. And the stakeholders look at it in amazement and think, all right, so what am I going to do now? So I think, we need to move beyond just, very useful in a way, rich, detailed descriptions of system complexity to actually supporting stakeholders to do something useful with that afterwards. Next slide, please. And that is where it's different from traditional approaches. I mean, that is where traditional approaches have, because of their simplicity in many ways, an advantage. Because traditionally, we start with identifying a hazard, assessing the associated risk, and then the improvement interventions are risk controls. And there is a clear message here. We've got a hazard, these are the risks, and this is how we control the risk. In FRAM, on the other hand, where we shine a light on system complexity, as you all know, when you want to intervene in a complex system, there are ripple effects, there are uncertainties, and the impact is never quite as easy to illustrate. So that is another challenge. We need to really think about, how do we communicate our intervention so that it makes sense to stakeholders, and how do we evidence these interventions? Because it's much harder to evidence an intervention which is probably multiple interventions looking at different things in a complex system. Next slide, please. And this is just an illustration. So, for example, take in the petrochemical industry, you have a road tanker, and they offload some kind of hazardous material to a storage facility. One of the hazards is you can overfill it, and then you have hazardous material spilled. So you have understood your hazards and your risk associated with it, and then you can have some kind of risk control measure, for example, an overfill alert or an automatic shutdown, and everybody will comprehend how your intervention links to your analysis and what the impact of that is and how you audit and assess it. On the right-hand side is something from a FRAM analysis which I did in radiology. And in radiology, people were saying, actually, we have plans in the morning, but come lunchtime, everything will have changed because there are so many uncertainties. Shift changes have taken place, new patients have come in, and things just, change a lot. So what we really would need is something to reset the day. And so, the idea of an afternoon huddle, for example, to help them coordinate and manage the complexity and the uncertainties was introduced. But actually that team huddle or that afternoon huddle can have lots of different implications. It can strengthen team cohesion, it can provide opportunities for communication and so on and so forth. So again, evidencing the impact of that is much harder, and it's not linked directly to a hazard as such. So that creates challenges, and I think we need to address these challenges head on. Next slide, please. And then there's, of course, the other issue that, the interventions go through multiple hands. In the book, we call this protecting the intent of recommendations, because, we as analysts, we have understood the system complexity, but then we try to communicate and hand this over to managers typically who hold the resources for authorizing interventions. And they need to convert it then into something for operational and frontline staff. And what we often, no, I shouldn't say often, what we can see, sometimes happen is that in that translation process, the intent of the FRAM recommendations, which are about strengthening resilience, get distorted. And all the variability which we evidenced, which typically is helpful, as Eric never tires of telling us, is actually then transformed into something, okay, we need more standardization, we need more checklists to constrain that variability. So it's going from understanding the role of variability to suddenly, let's just squeeze it into a tight box, into an action plan for frontline workers. So that distorts the intention of the recommendation. Next slide, please. And then, of course, you have skeptics. And, I think, again, we need to address this. We need to not sell the FRAM. What we really need to do is kind of illustrate how using the FRAM we can support the concerns of stakeholders. And, frequently raised objections are something like, why on earth would we spend a lot of resource on understanding, our everyday work, which works well, when we have incidents we need to study, for example. I mean, that's a typical one. Or on the other hand, if you just look at intervention by intervention, the outputs of FRAM recommendations, maybe they don't look kind of surprising or unique. And people would say, well, actually, we could have just done a quality improvement project, would have arrived at the same thing in much, much shorter time. And then, of course, there's the ever-present one. We know about it, but we can't do anything about it. It's beyond our control. And that is a typical issue which we're faced with when we make systems level recommendations, that people at the sharp end often don't have the authority to make those changes, and that can lead to frustration. So in the book, we have some suggestions. Next slide, please. And these are, not necessarily evidence-based. These are just, from our own experience. But I think what is important is when we undertake a FRAM project, FRAM analysis, we need to start talking in the language of the stakeholders. So we need to link FRAM to what matters to the stakeholders, their concerns, not just saying, oh yeah, it's great, we can show you all about variability and complexity. Fine, probably no one cares really, apart from methods geeks. So that is something to consider. Protecting the integrity of recommendations so that the rich picture of variability and resilient behavior or performance doesn't degenerate to let's constrain and reduce variability. And lastly, I mean, that's a shout out really to everyone. We need to start building the evidence base to demonstrate the impact of FRAM. I would actually say in order to do that, we need to develop frameworks for evaluation, because current frameworks where we just look at whether it reduces the number of incidents is probably not suitable for that kind of approach, which is rooted in complexity science. Thank you, Ricardo.
Thanks, Mark. That was excellent to me, and I think summarize the entire perspective of the book, which is about being users of the FRAM, but being critical users of the FRAM, and making sure that the effort we spend in that is actually relevant for some stakeholder in general, and not just for the sake of writing another journal article. I think here we have your context, and again, thank you also to Olivia who contributed to this chapter as well. So, you know, we are at the end of the journey. I just still have a couple of slides here, which is essentially, you know, in short, you saw 4 different cases, different domains, different approaches, different ways of doing that. They all have one thing in common, like they prove that you can use the FRAM for modeling your process, whatever it is. You know, there are very fancy application of FRAM used to model movies, or you know, to model very complicated space operations. But in essence, you can FRAM it. I mean, pick whatever, you can do your FRAM model. The real question is, should you? I mean, to which extent, to obtain what? And Mark already introduced that each chapter gives their own lens based on, again, various experiments, various exercise, various relationships with industry stakeholders to see when is the right moment to do so, or to which extent is helpful to answer a certain research question. At the end, you will also find an epilogue, which is short but kind of pointing at what the other chapter says, and this is evocatively called "to FRAM or not to FRAM." Someone would say this is the question, or this is what the epilogue is about. Again, this is something that is we try to show in the introductory part, but here again, you see the book is divided in sections. Each one has their own focus, and each one is devoted to certain domains. You see domain expert focus, or to certain methodological focus. You know, you will get this if you are somehow accessing the book. You will get this at the very beginning, so you know if you want to read it from A to Z as a curious reader, or you want to just focus on certain things that somehow resonate with what you are more interested in. From here, you also see the list of authors, and I guess for those of you familiar with FRAM literature, you will spot many frequent names, or many well-known names. I'm very happy that all these experts somehow accepted the challenges of writing a chapter in the summer 2023 and stand with me and Taylor and Francis to make this happen just a couple of years later. You know, I think all in all, as an editor, as an author of certain chapters, as a reviewer as well, this is another clear example of the dichotomy between work as imagined and work as done. So the journey was somehow definitely much more effortful than what I planned at the beginning. But I have to say, it was effortful, but equally rewarding, and I hope that will be somehow equally important, or even more important, for those who are interested in learning learning about the FRAM. So I hope this will be a resource you can take advantage of for exploring your work processes. There is some information in case you want to read exactly the content of those who presented today and all the other chapters. You have a link, a book available, officially launched tomorrow, by the way, in the Taylor and Francis repository. But you know, we'll keep that as a final image to say, you know, we give you some hints. We try to summarize the literature about the FRAM. We try to give you reflective perspectives on how certain methods, certain extension gave additional value in certain domains or in other domains. Essentially, you have a sort of summary of compendium on how the FRAM can be used and has been used successfully or unsuccessfully in various domains. I'm interrupting this again, thanking once more IEA for the support in arranging this and organizing this, and I'll ask my colleague to show to activate their webcam. Yeah, thank you. I see one question for the moment, which I will try to answer now, and asking to my colleagues who wants to lead the first response to that. Given the moment where it came out, probably Mark may be the one whose this question is directed. And we have something that says like, it sounds like you are suggesting to apply human-centered design. I guess that's ACD here in this context to FRAM. What's your view, Mark, on that, if that applies to you? You're muted, I think.
Yeah, I just realized I was jumping straight in. Well, in many ways. So whether I would call it human-centered design or participatory ergonomics or whatever, but I think one of the key issues really is that we need to work collaboratively with the stakeholders, not just as information sources, as we try to uncover the complexity and the variability in the system, but as we move forward with recommendations and then implementing the recommendations into something which is a sustainable change. I think it is absolutely essential to draw on the experiences, for example, from participatory ergonomics, where there is a wealth of knowledge we can draw on and integrate. Yeah.
Yeah, and I think the same applies to the following question we got, that is, how about FRAM within core design research? That's around the same vein and shows that it is exactly one of the approaches that can be useful and should be in the toolbox of an analyst who wants to do real socio-technical investigation. I think there is another one. Probably I would direct that to Ari, because okay, thank you for all excellent presentation, highly appreciated. I still feel the resonance and close weak coupling of functions underdeveloped, although interdependency looks helpful. So what is your view, Ari? Like what, I mean, can you give an example? And I know we work together on something, so probably I have something in mind, but can you give an example of where interdependency can add value to showcase the coupling of functions, and to which extent?
Yeah, so first of all, I would say that interdependence analysis is just a feature. It's but another feature which can be used when it is useful, but it is, I think, an extension to what Mark was saying. It needs to be useful from the perspective of the goal that your analysis tries to reach. So yes, I can think of many examples, interdependence analysis, but it's not the magic solution to every problem in the world. That's a disclaimer.
Yeah.
So that being said, yeah, for example, in human-robot collaboration, you would have something where you have these functions where people physically work together with robots. And it's not only the power that is provided, the output in terms of performance, the output in terms of timing. It's also the coordination between two agents. And many things can come together simultaneously. Observing an instrument while also acting in synchronization with a robot physically is very challenging. So I can see how with interdependence analysis you can decompose, or better said, even not decompose, but destructure, so to say, the whole system into several elements, and then come to a better understanding of where these things combine into functional resonance. And I agree with the question that it is indeed a bit under development. So there is still work to do there.
Yeah, and trying to wrapping up as we're running out of time, I think that's again another trigger for core design research into FRAM. So like involving practitioner to raise a good question, to define a meaningful scope for the investigation. There is a chapter by Jeanette Ausgaard, which is really about setting up the scope and framing questions to help setting up the scope in a way that is usable by the end user. But then when you set up the scope, making sure that the data you get, the validation you get, and eventually the results you get are valuable. And I guess Tarcísio also mentioned that with a real case in a sterile unit, giving the essence of practical recommendation, which somehow resonated with the operators. So thank you for all positive comments. We see other positive ideas coming up or positive observation. But conscious also of the time, I'm closing somehow the webinar here with first housekeeping thing. So we are going to share a small quiz once we close the webinar, and that will be required in case you want to get a certificate, so you will access that after the quiz. And even more importantly, as we are closing this webinar, this reflection on the FRAM, and again, using the launch of the latest FRAM book as a trigger for this webinar, I want to sincerely thank all our speakers for their very constructive contribution and reflections, both to the webinar today and to the book. And of course, thanks to IEA for the logistical support to deliver this. And clearly, thanks to all of you for joining us today, for being so patient. And maybe I know some of you are in a very late time zone or very early time zone, so that's even more appreciated, all effort you made. So, to summarize, this book is a collective effort. So I was very lucky to be trusted by several authors and colleagues to contribute to that. But it's a collective journey that connects both researchers, practitioners, and even friends in many cases, who share the curiosity for how complex systems work. My personal hope is that this book will not just serve as a reference, mainly as a reference, but also as an invitation. So an invitation to continue exploring, to raise questions, to somehow see the potential for resonance in various places. And again, thank you for being part of this moment. Thank you for being part of this webinar. And hopefully, I invite you to continue participating in the FRAM discussion and help the thinkers around socio-technical modeling, so the community of those thinkers to grow and evolve. That being said, I wish you all a very good day or good night, depending on where you are in the world, and fair winds as we all keep navigating complexity in our everyday world. Farewell.